Good morning, students. Today there is a paper discussion based on two topics. One is surface chemistry and next one is carboxylic acids. In surface chemistry, actually three different concepts we have. First one is adsorption and absorption. Second one is regarding catalysis and third one is colloids. So today's paper based upon only colloids and carboxylic acids. Carboxylic acid is another unit in the topic aldehydes, ketones, and carboxylic acid. So here from the colloids, from the surface chemistry, and carboxylic acid from the topic aldehydes, ketones, and carboxylic acid. So already synopsis as well as theoretical part based on colloids as well as carboxylic acids is completed. So today we have to proceed for the discussion of objective questions based on these two concepts. One is going to be colloids and next one is carboxylic acids. So first question, if the dispersed phase is a liquid, dispersed phase is going to be liquid and dispersion medium is going to be solid, then the colloid solution is known as. Whenever the solid is present in case of liquid, generally it is called as sol. Solid is present in liquid, generally it is called as sol. Now, liquid is the corresponding dispersed phase. Here, liquid is present in case of solid dispersion medium. Then it is opposite to that one. It is commonly known as gel. So, gel is the correct answer for this one, where liquid is dissolved in case of solid. This is acting as a DP, and this one is acting as a DM. When DP is liquid and DM is solid, the respective colloid is known as gel. So option number 3 is going to be correct. Sol is applicable for what? Solid in liquid is generally called as sol. Emulsion is applicable for both are found to be liquids, that is dispersed phase and dispersion medium. If both are found to be liquids, it is commonly known as emulsion. And foam is applicable for the presence of gas in case of what? Liquid. Whenever gas is present in liquid, it is generally called as foam. Now here for this question, option number 3 is correct. Question number 2 here, the stability of lyophilic colloids is due to, out of two different types of colloids, lyophilic and lyophobic colloids. Lyophilic colloids are generally stable colloids and compared to lyophobic colloids. They're asking here, what is the reason for the stability of lyophilic colloids? Charge on their particles, a layer of dispersion medium on their particles, the smaller size of their particle, the larger size of their particles. So mainly, lyophilic colloids are stable when compared to lyophobic colloids because of two reasons. One is found to be the degree of solvation. Lyophilic colloids undergoes a process of solvation easily when compared to lyophobic colloids. That is the main reason. Second one is found to be the charge. When compared to charge, the stability of colloids is mainly because of the what? The degree of solvation or hydration. Here, charge on their particle is going to be that this is not considered here. Layer of dispersion medium on their particle to some extent, smaller size, it is not found to be correct. Larger size of the particle, question of size of the particle is not related to what stability. It is presence of dispersion medium around the particles of the lyophilic colloid. Because of that reason, so a layer of dispersion medium on their particle is responsible for stability of colloid. Compared to that one, more appropriate answer is found to be the stability of lyophilic colloid is mainly because of the presence of what? The degree of hydration or degree of solvation. They undergo the process of hydration. Due to that reason, they are found to be stable colloids. Question number 2, option number 2 is correct. Question number 3, some of the properties given below are for colloidal solution. Properties are mentioned here. Viscosity is same as that of medium. Extensive hydration takes place. Migration of the particles under electric field, and particles cannot be detected even under ultra microscope. So next one, it is found to be properties applicable for lyophilic colloids, and next one is found to be lyophobic colloids. Sols are. These are applicable for this one. Line is going to be there here. These two properties are applicable for lyophilic and next one properties are applicable for lyophobic. Out of these four properties, which properties are corresponds to lyophilic colloids and which properties corresponds to what? Lyophobic colloid. We have to identify that one. So out of these particular one, viscosity is same as that of medium means this is the property of lyophobic colloids. In case of lyophobic colloid, viscosity of dispersed phase and dispersion medium is found to be almost same. Extensive hydration takes place, just now we have discussed. Hydration takes place in case of only lyophilic colloid. This is a property of lyophilic colloids. Migration of the particles under electric field, this is the property of again lyophobic colloids. Compared to the lyophilic colloids, migration is maximum in case of lyophobic colloids, and particles cannot be detected even under ultra microscope because of the presence of small charge. This one is a property of lyophilic colloids. So first one is lyophobic, next one is third one is found to be lyophobic. First one and third one are found to be lyophobic, means this one, and second one and fourth one property are applicable for second is lyophilic colloid and fourth one is also lyophilic colloid. So option number 3 is found to be correct for this one. So out of 4 properties given here, first and third properties are applicable for lyophobic colloid, second and fourth properties are applicable for lyophilic colloids. Question number 4. Gelatin is mostly used in making ice cream in order to. Generally, gelatin is added in the preparation of ice cream. Basically, ice cream is an example for lyophobic colloid. It undergoes the process of coagulation. In order to prevent the coagulation of the ice cream, they are adding gelatin substance. Here, gelatin serves as a protective colloid, or it is also called as lyophilic colloid. Whenever lyophilic colloid is added into lyophobic colloid, this lyophilic colloid prevents the coagulation of the lyophobic colloid. So, gelatin serves as a lyophilic colloid and ice cream is acting as a lyophobic colloid. Prevent making of colloid, this is not found to be correct. Stabilize the colloid and prevent the crystallization. It undergoes the process of coagulation easily. To prevent that coagulation, we are adding certain amount of gelatin to stabilize the mixture, to enrich the aroma. That is found to be incorrect. Only correct option is found to be to stabilize the colloid and to prevent the process of crystallization. So second option is correct for this question. Question number 5. The stability of the dispersed phase in a lyophobic colloid. Lyophobic colloid is as stability of dispersed phase in a lyophobic colloid is due to high viscosity of the medium, formation of electrical layer between the two phases, high surface tension, and none of this. In case of lyophobic colloid, generally we have observed that presence of the preferential adsorption of ions takes place on the surface of the particles. Now this is found to be AgI, and here we can observe the presence of Ag plus. Between this one and again one more layer is going to be there called as, this is found to be another particular substance is going to be there, either I minus or corresponding K minus will be there, K plus will be there. So those particles are present around the particles of the dispersion medium. Between these particles and between the next particle, there is a presence of electrical double layer. It is also called as electrokinetic potential or zeta potential. That electrical double layer is going to be present between the phases. Because of that reason, lyophobic colloids are stable to some extent. But between lyophilic and lyophobic, if you observe, lyophilic colloids are found to be more stable when compared to what? Lyophobic colloids. So question number 5, second option is correct. The process of separation of colloids by passing through semi-permeable membrane is called filtration, electrophoresis, dialysis, and next one is found to be ultrafiltration. Filtration is generally done by the process of filtration, that is by using common filter paper. There, by using common filter paper, it is not possible to separate, or it is not possible to filter the colloid, because size of the pores in filter paper is found to be larger one. Both the true solution particles as well as colloidal particle pass through the filter paper, so this process is not applicable here. Electrophoresis, the process of electrophoresis is applicable for the detection of the charge present on the colloidal particle. Whether the colloid is negatively charged or positively charged, to identify that one, we use the electrophoresis. Here they are asking about separation of colloids by passing through semi-permeable membrane is commonly called as the concept of dialysis. Dialysis is generally applicable for the purification of colloids. The process of removal of true solution particles, excess amount of true solution particle from the colloidal sole by using semi-permeable membrane or parchment membrane is commonly called as what? Dialysis process. Dialysis is applicable for the process of separation of the colloid from the true solution particle. So correct option for this one is third one. Ultrafiltration. This can be done by dipping the filter paper in case of a solution of colloid ion. Colloid ion is going to be generally used for the conversion of larger size pore into smaller pore size. For that purpose, we are using colloid ion. So this is applicable for the separation of colloid. But here, by passing semi-permeable membrane means the correct option should be only dialysis. Question number 7. The stabilization of dispersed phase in a lyophobic colloid is due to stabilization of dispersed phase in lyophobic. Already, just we have considered the same question. The adsorption of the charged substance on the dispersed phase, large electrokinetic potential developed in the colloid. Next one, viscosity of the medium, formation of the electrical layer. Just now I explained about formation of electrical layer or zeta potential is going to be, that is the main reason for the stability of lyophobic colloids. Question number 8, the size of colloidal particles varies from. In any colloidal solution, particle size is ranging in terms of meter. It is 10 to the power of minus 9 to minus 6 meter, or in terms of nanometer, it is ranging from 1 nanometer to what? The 1000 nanometer. This is a general thing that is applicable for the size of the colloidal particle minus 9 to minus 6 meter, or it is going to be 1 nanometer to 1000 nanometer. Here, so minus 7 to minus 9 is there, minus 9 to minus 17 is there. There is a printing mistake is going to be considered. So correct option should be minus 9 meter to the 10 to the power of minus 6 meter. So this answer is going to be correct. It's there. It is because of printing mistake, no option is said to be correct. Ninth one, Tyndall effect is shown by. Tyndall effect is shown by colloidal solution, osmotic solution, isotonic and hypertonic solution. Tyndall effect is commonly observed in case of colloidal solution because of the scattering of the light. So this phenomena of Tyndall effect is observed in case of colloidal solution. So only option number 1 is correct. Osmotic solution, whatever the colloidal solutions are there, those colloidal solution exhibit very, very low amount of colligative properties. Osmotic solution cannot be considered. Isotonic solution, that is also not related to this one. Hypertonic is also not related. Only colloidal solutions exhibit the concept of Tyndall effect. Ninth one, it is first question. Question number 10, which one is an example for multi-molecular colloid system? So depending upon the size of the particle, colloids are basically classified into 3 different types. One is called as multi-molecular colloid. Next one is called as macromolecular colloids, and third one is called as associated colloids. In case of multi-molecular colloids, the particles of the substance are aggregate together. Smaller size particles are going to be aggregate together. That results in the formation of solution in which particle is going to be ranging from. So these are example for multi-molecular colloids. Second one is called as macromolecular colloids. Macromolecular colloids, you have observed the presence of polymers. Polymers maybe there are biomolecules. Proteins are going to be there. Proteins. Next one is going to be enzymes. After that, different types of polymers. All these substances are example for macromolecular colloid. Third one is commonly called as associated colloid. Soap solution is an best example for associated colloid here. Soap is dispersed in water, means this is an example for associated colloid. It is example for associated colloid. Next one, protein dispersed in water is going to be an example for, it is macromolecular colloid. This is commonly called as macromolecular colloidal solution. And next one, gold dispersed in case of water. This gold dispersed in water is an example for multimolecular colloid. This is an example for multimolecular colloid. Multimolecular colloid. So third option is going to be correct. Gum dispersed in case of water, that is a simple colloidal solution. It is not considered under these 3 categories. 11th one, the number of phases in colloidal system are. Every colloidal system, it consists of dispersed phase and dispersion medium. Dispersed phase is just like what? Solute, and dispersion medium is just like what? Solvent. When how solute is added to solvent to form the respective solution, like that dispersed phase is added into dispersion medium to form the respective colloidal substance. So every colloidal substance consists of 2 components. One is called as dispersed phase. Next one is called as dispersion medium. So these are the 2 components present in case of the colloidal solution. 12th one, smoke is a dispersion of. What is smoke? Smoke particles are there, dust particles are going to be there. Those particles are nothing but presence of the solid dispersed phase present in large amount of air, that is going to be gas. So wherever the solid is present in case of gas, presence of solid in gas is an example for this particular smoke. Solid is acting as a dispersed phase and gas is acting as a dispersion medium. So this solid is present in gas. It is commonly called as, so that is third option, solid in gas. Gas in gas doesn't form any type of colloidal solution because it forms an homogeneous mixture. Gas in case of solid, it is commonly called as the corresponding form. Next one, liquid in gas. Liquid in gas is going to be called as liquid aerosol is going to be there. So for this question, solid in gas is going to be the correct answer. Question number 13. The colloidal salts are purified by peptization. First one is given as peptization. Peptization is a method of preparation of colloid. Conversion of and precipitate into colloidal solution by adding in suitable electrolyte containing common ion is commonly called as peptization. It is not there. Coagulation. Coagulation is nothing but it is a process of conversion of colloid into precipitate. Conversion of colloid into precipitate is called as coagulation. Conversion of precipitate into colloid is commonly called as peptization. Dialysis is going to be there. It is a method of purification of colloid, and flocculation that is applicable for the coagulation of colloids. They are asking colloidal solutions are purified by. Dialysis is a method applicable for the purification of colloid. What is the definition of dialysis, students? Dialysis is defined as the process of removal of true solution particle from the colloidal sol by using semi-permeable membrane or parchment paper is commonly called as dialysis. In this one, we are able to remove maximum amount of true solution particle from the respective colloid. So dialysis is the correct answer for the purification of colloids. 14th one, Bredig arc method cannot be used to prepare colloidal solution of which of the following? Bredig arc method is one of the method for the preparation of colloids, especially lyophobic colloids. There, metals of low reactive nature. If any metal is going to be there which is not having affinity with water or any particular solvent, generally such type of metal sols are prepared by using Bredig arc method. Gold sol is going to be there, silver sol is there, platinum sol is there, copper sol is there. Wherever low reactive metals are going to be there, low reactive metal sols are prepared by using Bredig arc method. Here question is, Bredig arc method cannot be used. First one, platinum, low reactive metal. Iron is going to be there, more reactive metal. Az and gold is going to be there. Au, Az and platinum are found to be low reactive metals. Such type of metals can be converted into respective metal salts by using Bredig arc method. But this Fe is found to be a reactive metal. It can combine with water easily. So this particular metal salt cannot be prepared by Bredig arc method. It is applicable for the preparation of only such type of metal salts where metal is less reactive in nature. Question number 15. The stability of hydrophobic sol is due to, already I have mentioned between lyophilic and lyophobic, hydrophilic and hydrophobic sols. Generally, hydrophilic sols are much more stable. But here, to some extent, stability of hydrophobic sol is found to be due to solvation of colloidal particles, charge on the colloidal particles, size of the particle, and none of the above. So lyophobic colloids or hydrophobic colloids are found to be stable only because of the presence of charge. That is, electrical double layer is going to be present between diffuse layer and what the fixed layer. Between fixed and diffuse layer, there is a presence of electrical double layer. There is presence of charge going to be there. This presence of charge is responsible for the stability of respective colloidal solution. 16th one, lyophilic sols are more stable than lyophobic sols. Yes. Generally, lyophilic colloids are found to be more stable when compared to lyophobic colloids. The main reason for the stability of lyophilic colloids is found to be they are heavily hydrated. Extent of hydration is maximum in case of lyophilic colloid. So first one, colloidal particles of positive charge. This is found to be incorrect one. Particles are having negative charge. This is found to be incorrect. Colloidal particles are solvated. Just now I told these particles of the colloids are heavily hydrated, heavily solvated. They undergo the process of hydration easily. Due to that reason, lyophilic colloids are found to be more stable when compared to lyophobic colloids. So there are strong electrostatic repulsion between negative charged colloidal particles. This is also found to be incorrect for the stability of lyophilic colloids. Only third option is correct here. 17th, lyophilic colloid sols are more stable than lyophobic colloids. Again, same question. Because their particles are positively charged, negatively charged. Question of charge is not applicable. Soluble. Soluble refers to, again, here we can say the process of hydration itself. Either you can say hydration or you can say solvation. Because of the solvation, these lyophilic colloids are said to be more stable when compared to what? Lyophobic colloids. Question number 18. Which of the following statement is false for the hydrophilic sols? They are asking about hydrophilic sols here. Which of the following is going to be correct for hydrophilic sols? Question number, okay. 18th one, which of the following statement is false for, incorrect for hydrophilic sols? They do not require electrolytes for stability. This is not applicable for this one. Their viscosity is of the order of that water. This is applicable for corresponding hydrophobic sols, that is lyophobic sol. Viscosity as well as surface tension is going to be dispersed phase. Viscosity and surface tension in case of lyophobic sol is almost equivalent to corresponding dispersion medium. So this is the correct statement. It is incorrect for lyophilic sol or hydrophobic sols. So viscosity of the order of that water means this is applicable only for lyophobic sol. It is not for lyophilic sol. So this is a false statement for the lyophilic colloids. Their surface tension is usually lower than that of dispersion medium. This is found to be correct. I mean, statement is found to be, that is what they are asking about incorrect statement. None of this, that is only second option is correct here. Question number 19. Which of the following is contributed towards the extra stability of lyophilic colloids? Maximum questions are there based on stability. Which of the following is contributed towards the extra stability of lyophilic colloid? Hydration, charge, color, and Tyndall effect. Tyndall effect is nothing to do with the lyophilic and lyophobic colloid. Between lyophilic and lyophobic, which one exhibits Tyndall effect to the maximum extent? Lyophobic colloid. Lyophobic colloids exhibits maximum amount of Tyndall effect when compared to lyophilic colloids. Color, charge, next one hydration. Already have mentioned number of times. Hydration or solvation is the main responsible factor for the stability of lyophilic colloids. Because of excess amount of hydration or solvation, these lyophilic colloids undergoes the lyophilic colloids are found to be more stable. Generally, they do not undergo the process of coagulation easily. So hydration is the main responsible factor for the stability of lyophilic colloids. Question number 20. Arsenious sulfide is positive colloid, negative colloid, neutral colloid, and this is found to be none of this. Arsenious sulfide is a well-known example. This arsenious sulfide, it can be obtained by mixing arsenious oxide with certain amount of hydrogen sulfide. This is an example for negatively charged colloid. This colloid is an example for negatively charged colloid. What is the meaning of negatively charged colloid? The particles of the dispersed phase dP is carrying what? Negative charge, and dispersion medium is carrying equal and opposite charge. Wherever the dP carries negative charge, the colloid is commonly called as negatively charged colloid. And suppose if dP carries positive charge, it is called as positively charged colloid. So depending upon the charge present on the dispersed phase, the colloid can be classified into negative or positively charged colloid. But basically, if you think about the overall charge present on the colloidal solution, it is found to be neutral because of the presence of equal and opposite charge in case of dispersed phase and dispersion medium. So this one is an example for negatively charged colloid. Question number 20, second option is correct. Which of the following statement is not correct for lyophobic solution? Is not correct for lyophobic solution. Students, you have to observe carefully about the question. Not correct is asked here. It can be easily solvated. Lyophobic colloid cannot be solvated easily. This statement is found to be not applicable for, it is applicable for actually for lyophilic colloid. They are asking not correct means this statement is found to be not correct for lyophobic colloids. Lyophobic colloids generally do not undergo the process of coagulation. Here it is given that it can be easily solvated. They are asking about the wrong statement. So first option itself is the correct option because this statement is not correct. It carries charge, that is correct. The coagulation of this sol is irreversible in nature, that is correct. It is less stable than the solvent, that is found to be correct. So only first option is found to be correct for this one. 22. Fog is an example for liquid, solid dispersed in gas, liquid dispersed in gas, liquid dispersed in solid, and solid dispersed in case of liquid. Whenever solid is dispersed in case of gas, it is commonly called as solid aerosol. It is commonly called as solid aerosol. Liquid is present in case of gas. This is an example for fog. Next, a liquid is dispersed in case of solid. When liquid is dispersed in case of solid, it is commonly called a gel. Solid is dispersed in corresponding liquid is commonly called as sol. These are the various types of colloidal solutions depending upon the presence of different type of dispersed phase and dispersion media. So here they are asking about fog. Fog is an example for liquid that is present in case of gaseous medium. Second option is correct. 23. The colloidal system consisting of a liquid adsorbate in solid adsorbent is found to be. Liquid adsorbate means liquid is acting as an DP. This is present in case of which one? Solid adsorbent. Here solid is acting as an DM. Means liquid is present in case of solid. Whenever liquid is present in case of solid, what is that particular colloid? It is commonly called as gel. Liquid is present in solid means it is called a gel. Solid is liquid. Solid is present in the case of liquid is commonly called as sol. So the best name given for this particular colloidal solution is found to be gel. So fourth option is found to be correct. Liquid adsorbate means this is present in smaller quantity. It is acting as a DP. Solid adsorbent means this is present in maximum substance, maximum quantity. It is acting as DM. So liquid is present in solid means it is commonly called a gel. So fourth option is correct for this question 23. 24. The redispersal of a freshly precipitated substance into a sol by the addition of an electrolyte is commonly known as aggregation, condensation, coagulation, peptidization. This process, this definition is applicable for peptidization process. What's the meaning of peptidization? The process of conversion of freshly prepared precipitate into a colloidal sol by adding a suitable electrolyte, preferably containing common ion, is called as peptidization. Whatever this statement is applicable here, that is only for process of peptidization. It is not the process of aggregation, condensation, and coagulation. Coagulation is the reverse of this peptidization process. It is also not correct. So only fourth option is correct for this statement. 25. Moment of colloidal particles under the influence of electrostatic field is. Moment of colloidal particles under the influence of electrostatic field is commonly called as. This process electrophoresis, electrolysis, dialysis, and ionization. Ionization is not applicable for this one, and dialysis is a method of purification of colloids. Electrolysis is also not applicable here. Electrophoresis process. Electrophoresis is a method to determine the charge present on the colloidal particles. Whether colloid is a negatively charged colloid or a positively charged colloid, that can be determined by using the process of electrophoresis here. So, the moment of colloidal particles under the influence of electric field is commonly called as electrophoresis. It consists of an U-shaped glass tube. In that U-shaped glass tube, you have to fill the corresponding colloidal substance. It is having two different types of electrodes are going to be fitted here. This is found to be an negatively charged electrode, and this one is found to be an positively charged electrode. When the positive and negatively charged electrodes are going to be present here, so this is found to be an colloidal solution is going to be filled in this one. If all the particles are migrating towards this one negatively charged terminal, then this one clearly indicates that colloid carries what? Positive charge, and this process is commonly called as electrophoresis process. Electrophoresis is a method for the determination of charge on the colloidal particle. If all the particles are migrating towards anode, it is carrying a positive charge. If the particles are migrating towards positively charged terminal, then those colloidal particles will carry negative charge. That colloid is called as negatively charged colloid, and this concept is known as electrophoresis process. Question number 26. Bleeding is stopped by the application of ferric chloride. This is because wherever there is a process of bleeding takes place, that can be stopped by ferric chloride. Ferric chloride is a substance which consists of active ion, that is found to be Fe+3. This Fe+3 coagulates with the blood particles which are found to be an negatively charged particles. When these negatively charged blood particles coagulates with the positively charged particles of the Fe+3, the process of coagulation takes place. Whenever the process of coagulation takes place, bleeding completely stops. Ferric chloride seals the blood cells. Blood starts flowing in the other direction. Blood is coagulated and blood vessels are found to be sealed, and none of this. So these two statements are incorrect. It is gets coagulated. Blood is going to be subjected to coagulation by applying certain amount of FeCl3, or one more substance is commonly used, that is known as potash alum. Potash alum is also acting as a good coagulating agent. The active ion present in potash alum is said to be Aluminium ion, this is the complete formula for the potash alum K2SO4 into Al2SO4 thrice into 24H2O. Here aluminium carries positive charge. These aluminium positively charged aluminium coagulates the blood particles. As a result, coagulation takes place, bleeding completely stops. So option number 3 is correct for the process of stopping the bleeding of blood. 26 correct option is found to be only third one. Gold number is associated with gold number. Only lyophobic colloids, lyophilic colloids, both 1 and 2 and none of this. What is meant by gold number? Gold number concept was proposed by Mr. Zsigmondy. According to him, gold number is nothing but, suppose if you take 10 ml of gold sol, if you consider the 10 ml of gold sol is there here, this 10 ml of gold sol is subjected to coagulation by adding 1 ml of 10% of sodium chloride solution. When 1 ml of 10% of sodium chloride is added, it undergoes the process of what? Coagulation. This coagulation is prevented by adding certain amount of lyophilic colloids. The coagulation of that gold sol is prevented by adding certain amount of lyophilic colloid. Lyophilic colloid is acting as a protective colloid. This protective colloid or lyophilic colloid prevents the coagulation of 10 ml of gold sol, which is subjected to coagulation by adding 1 ml of 10% of sodium chloride solution. This process is commonly called as what? Gold number. Suppose if you take different types of gold number, which one prevents the coagulation of 10 ml of gold sol? For example, X is going to be required about 0.05 milligrams. Y is going to be requiring about 0.5 milligram generally considered. Z is going to be requires about 10 milligram of this one, and another one substance A is going to be another colloid that is going to be requiring 0.25 milligram. Out of these 4 colloidal substances, lyophilic colloids, these are commonly called as lyophilic colloids, which prevents the coagulation of lyophobic colloid, that is gold sol. When 0.25 milligram is added, it prevents coagulation. A is going to be requires 0.25 milligram. X is going to be requires 0.05 milligram. Y requires 0.5 milligram. Z requires 10 milligram. Which is the best protective colloid or lyophilic colloid to prevent the coagulation of gold sol? It is said to be the substance X. X is going to be called as best protective colloid because just it requires 0.05 milligram to prevent the coagulation of 10 ml of gold sol. So, this gold number is inversely related to, concept of gold number is inversely related to, it is protective power of lyophilic colloids. It is protective power of lyophilic colloids. Greater the value of gold number, lower is the protective power. So here this is going to be having smallest value of gold number. So this particular colloid is having highest power of highest protective power. Because of that reason, this is going to be considered as best lyophilic colloid in order to prevent the coagulation of 10 ml of gold sol. So process of gold number is the property of only lyophilic colloids. Lyophilic colloids are also called as protective colloids. Those protective colloids prevents the coagulation of the lyophobic colloid. So that depends upon the value of gold number. So gold number and protective power of the lyophilic colloid are inversely proportional to each other. So option number 2 is correct for this question. 27th, second option is correct. It is applicable for the concept of lyophilic colloids. Which of the following colloids are formed when hydrogen sulfide gas is passed through cold solution of arsenious oxide? Hydrogen sulfide H2S is passed into arsenious oxide As2O3. What happens here? This is a double displacement reaction takes place. Take 3 moles of H2S here. Now, substance produced is said to be As2S3 plus this is going to be 3 moles of water. So this is the process of formation of an colloid here. This colloid is a negatively charged colloid is produced. So here, which of the following colloids are formed when hydrogen sulfide is passed through cold solution of arsenious oxide? When hydrogen sulfide gas is passed into this arsenious oxide, formation of As2S3 sol takes place. So option number 1 is correct for this question. 28, first option. 29. Milk is an colloid in which? Milk is the best example for emulsion, students. Emulsion is a colloid in which liquid dispersed phase is present in liquid dispersion medium. Liquid is dispersed in liquid. This is found to be correct. What is the name given for solid is dispersed in case of liquid? When solid is present in case of liquid, it is called as sol. Gas is dispersed in case of liquid, it is called as gas is liquid. This is going to be called as commonly fog. And some sugar is going to be dispersed in case of water. When sugar is going to be present in case of water, that is commonly called as sol. Solid is present in case of liquid. So correct option for this question is first one. Question number 30. Protective sols are lyophilic colloids, lyophobic colloids, both 192 and none of this. Just now I explained in case of concept of gold number. In the process of gold number, the protective colloids are commonly called as lyophilic colloids. So always protective colloids are nothing but lyophilic colloids, which prevents the coagulation of what? Lyophobic colloids. So protective colloids are nothing but lyophilic colloids, because lyophilic colloids are added into lyophobic colloids in order to prevent the coagulation of the lyophobic colloids. So question number 30, correct option is first one. 31. Alum purifies the muddy water by. Alum purifies muddy water by dialysis, absorption, coagulation, and this forming a true solution. Alum is, just now I explained about that. It is a compound containing potassium sulfate and aluminium sulfate, Al2SO4 thrice, with 24 moles of water molecule. This is commonly known as potash alum. This one purifies the muddy water by the process of what? Coagulation process. The coagulation process always takes place between the positively charged aluminium ion and the muddy particles or sand particle which carries negative charge. Between the positive charge of aluminium and negatively charged particles of that particular muddy water, process of coagulation takes place. All those particles are going to be deposited at the bottom of the container. Upper layer consists of the pure water. So the process of coagulation is involved in this case. Question number 32. These next questions are from the topic or carboxylic acid, that is organic chemistry. Question number 32. What is the correct about the following reaction? When this compound is called as 2-bromobutane treated with magnesium ethoxide followed by carbon dioxide and hydrolysis is going to be carried out. Which of the following is going to be correct here? First, we'll write the reaction here. CH3, this is CH2, next one CH and CH3 is there. It is a 2-bromobutane compound. First, it is treated with what reagent? Magnesium ethoxide is there. Whenever this compound is treated with magnesium ethoxide, the main compound produced here, it is CH3, next one CH2, this is CH and CH3, it is Mg and this one is Br. This is commonly called as a Grignard reagent. When this Grignard reagent combines with the carbon dioxide, you have studied about the preparation of carboxylic acid by using Grignard reagent. The same reaction I'll write here. When it combines with carbon dioxide here, the product is CH3, this is CH2, next one, it is CH, this is CH3, I'll write here. MgBr is going to be there, that is this bond is going to be gets completely cleaved, it carries negative charge and this one is carrying positive charge. In carbon dioxide, C double bond O and this is C double bond O. These electrons are shifted here, it carries partial negative, this is carrying partial positive charge. The entire alkyl group attacks on the carbon atom. Here I should write, this is going to be C, it is a double bond O, next one OMgBr. This is the intermediate product obtained here. Now this one further the process of hydrolysis is carried out here. This bond gets cleaved here, attack of oxygen takes place on that one. Now the compound is CH2, this is C. Next one it is CH3, this is going to be H and after that it is COOH. This is the final compound obtained in case of this reaction. In this final product, some statements are going to be given here. The major product is a racemic mixture of 2-methyl butanoic acid. Is it 2-methyl butanoic acid? This is number 1, it is second one, it is third one, this is fourth one. 2-methyl butanoic acid, this one forms in racemic mixture. Because all the 4 groups are found to be different, this carbon atom is said to be chiral carbon atom. So it is a racemic mixture obtained for the compound 2-methyl butanoic acid. The major product is achiral. This is not the question of achiral. If a pure enantiomer starting compound is taken, The major product would be a pure enantiomer of 2-methyl-butanoic acid. This is also incorrect. Major product will be an trans-butene. Question of this one does not arises. Only first option, it is an racemic mixture of 2-methyl. What is that? Butanoic acid. So option number 1 is correct for question number 32. Question number 33, the organic product formed in the reaction is found to be benzoic acid is treated with the lithium aluminum hydride followed by hydrolysis. Whenever a benzoic acid or any carboxylic acid is subjected to reduction in presence of lithium aluminum hydride followed by the process of hydrolysis, CO group gets converted into what? CO group gets converted into CH2 group. So formation of an alcohol takes place in this reaction. Formation of an alcohol. When the same compound is treated with hydrogen iodide in presence of red phosphorus, it is also reducing agent. The main product obtained in case of this one is found to be an hydrocarbon, that is found to be benzene. Here they are asking about only lithium aluminum hydride, so this will be the product. C6H5OH, this is found to be incorrect. This is found to be incorrect. This is also incorrect. This is also incorrect. Only correct option, correct product for this reduction is found to be an benzyl alcohol compound. What's the product here? Benzyl alcohol. So no option is found to be correct. Probably it's a printing mistake. 33 correct option is, correct answer is said to be benzyl alcohol, which is obtained by the reduction of what compound? Benzoic acid. 34, consider the acidity of carboxylic acids. 4 different types of carboxylic acids are the first one, PHCOH, means just I'll write in convenient manner. It is benzoic acid. Next one, orthonitrobenzoic acid is there. This is orthonitrobenzoic acid, COOH. Here ortho group is present. Ortho position, NO2 group is present. Next one, para-nitrobenzoic acid is there. COOH and para position NO2 group is present. After that, meta-nitrobenzoic acid, this is COOH and meta position, there is a presence of NO2 group. This is a simple compound, it is A, this is found to be B, next one C and next one D. Now here NO2 group is present, you know very well NO2 group it can exert the negative resonance effect. This is NO2 group and here also NO2 group and this is found to be NO2 group. Compared to all these compounds, this is the compound does not contain any type of electron withdrawing group. So this compound is found to be least acidic in nature. Between orthoisomer, para-isomer and meta-isomer, which compound is found to be more stable, more acidic in nature? Probably you heard about the concept of ortho effect. In case of ortho effect, if any substituent, whether it is an electron releasing group or electron withdrawing group is present at ortho position, that compound is always more acidic in nature. It is mainly because of ortho effect. So here compound B is found to be more acidic in nature because of the process of ortho effect. Next one, the question of resonance is not applicable at the meta position because of that reason. This meta-nitrobenzoic acid is least acidic when compared to para-nitro. After that, the option C. Next one compound is said to be D. And lastly, it is found to be A. Reason is that this compound does not contain any electron withdrawing group. So the correct order of acidity of these 4 compounds is found to be B, C, D, A. B, C, D, A means only option first one is correct. It is mainly because of the presence of this particular ortho substituent. Ortho substituted carboxylic acids are more acidic in nature when compared to para and meta-isomer, even though the substituent is considered as an electron withdrawing group or electron releasing group. 34, first option is correct. 35, carbolic acid is. Carbolic acid is general name of phenol compound. Phenol is generally called as carbolic acid, so only option 4 is correct here. 36, the correct order of increasing acid strength of the following compounds is. Okay. Correct order of acidic strength of these compounds. First one is the compound CH3COH, an aliphatic carboxylic acid. Second compound is OCH3COH2COH is there. This is CH3O. Next one CH2 and COOH, methoxyacetic acid. Next compound is CF3CF3. Next one COOH, trifluoroacetic acid. And last compound is a methyl group is present. This is CH. Next one methyl group is present. After that COOH is there. It is simple acetic acid. Next one is methoxyacetic acid, trifluoroacetic acid. This one is it is a 2-methyl propanoic acid is present. Out of these compounds, this is the fluorine atom is present which exhibits maximum amount of minus effect. You know about this compound, the value of pK of this compound is found to be less than 1. One of the strongest acid among all the carboxylic acid, that is trifluoroacetic acid, due to the presence of maximum amount of minus I effect. Trifluoroacetic acid is found to be strongest acid here. If you take, this is the compound A, or you can take 1 here, this is 2, next one is 3, and this is going to be 4th one. Out of all these 3 compounds, very clearly we can say that third compound is more acidic in nature when compared to remaining compounds. After that, next compound is going to be CH3COH and CH3OCH3. Here this one can act as an electron releasing group only in case of resonance effect. But here, because of the presence of oxygen atom, even it can exhibit certain amount of minus I effect. Whenever the compound contains electron withdrawing groups, either by minus R effect or by minus I effect, that compound is said to be stronger acid here. So compared to this one, extent of minus I effect is going to be less, and this compound is going to be a stronger acid out of these 4 compounds. First one is third, trifluoroacetic acid. Next one, this one, it is because of maximum highest amount of minus effect. This is also having certain amount of minus effect is considered here. Next one, it is a CH3 group, only one methyl group is there, but here 2 methyl groups are there. Now this compound is having maximum plus I effect, and this compound is having minimum plus I effect. The compound with minimum plus I effect is always said to be more acidic in nature when compared to the compound with maximum plus I effect. As the electron releasing nature goes on, increases, acidity of the compound goes on, decreases. After that, it is found to be first compound, and the least acidic compound is said to be 4th one. 3, 2, 1. For they're asking about increasing order. Increasing order means reverse. You have to take 4, 1, 2, 3. 4, 1, 2, 3 means only option is third one. Clear, students? This is mainly because of the presence of electron releasing or electron withdrawing groups. 37. When propanoic acid is treated with aqueous sodium bicarbonate, carbon dioxide is liberated. The carbon of carbon dioxide comes from, okay, propanoic acid is there, CH3, next one CH2, after that COOH. When this is treated with sodium bicarbonate, that is NaHCO3. Now the formation of respective sodium salt formation takes place. COO, this is Na, plus H2O is produced, and carbon dioxide is produced. Whatever hydrogen of this acid is there, this one combines with the hydrogen of this sodium bicarbonate, that results in the formation of water, and this carbonate is going to be converted into respective carbon dioxide. This carbon of carbon dioxide does not obtain from the carboxylic acid. In turn, it is obtained from the carbon of respective sodium bicarbonate. Methyl group, it is not found to be correct. Carboxylic acid group, it is not correct. Methylene, question of methylene is not present. It is bicarbonate. The carbon of carbon dioxide comes from the respective bicarbonate compound. Complete H is going to be replaced by sodium. So no question. It is not obtained from the respective acid. It is obtained from the sodium bicarbonate compound. So 4th option is correct here. 38. In the reaction, what is the compound C? Let us write the reaction. CH3COOH is there. That is acetic acid combines with the lithium aluminium hydride. When it combines with the lithium aluminium hydride, you know very well, this is converted into CH3, this is CH2OH, ethyl alcohol. Ethyl alcohol is treated with a PCl5, phosphorus pentachloride. The compound produced here, it is CH3, CH2, this one is Cl, ethyl chloride. Ethyl chloride and treatment with alcoholic KOH. What is the role of alcoholic KOH? It is acting as a good dehydrohalogenating agent. Removal of halogen and hydrogen takes place. When hydrogen and halogen gets removed, the product, final product is said to be an alkene compound. This is an ethene, acetaldehyde, acetylene, ethylene, and acetyl chloride is there. Correct option is said to be ethylene. First one, reduction takes place after one chlorination. Next one is going to be dehydrohalogenation. For final product is said to be third one. Question number 39. Which of the following reagent may be used to distinguish between phenol and benzoic acid? phenol and benzoic acid. Two compounds are given. Which reagent is used to distinguish between phenol as well as benzoic acid? Both are acidic in nature, but carboxylic acids are more acidic when compared to phenolic compounds. Aqueous sodium hydroxide, both will react with sodium hydroxide because they are acidic in nature. Tolerance reagent, none of these compounds react with the tolerance reagent. It is a test for only aldehyde compounds. Molish reagent, it is not applicable for these two compounds. Neutral ferric chloride, yes, this phenol combines with neutral ferric chloride, it forms a violet color. Formation of violet color takes place because of the presence of phenolic OH group, but this carboxylic acid does not produce any type of violet color. There is no reaction takes place. So, neutral ferric chloride can distinguish between an phenol and respective carboxylic acid. Other compounds, other reagents cannot be used. Only it is found to be neutral ferric chloride, where phenol gives a positive test and benzoic acid or any carboxylic acid gives negative test. Next question, 39, fourth option is correct. Question number 40, the acid which reduces Fehling solution is. Fehling solution is applicable for the test for the aldehydes. Methanoic acid, ethanoic acid, butanoic acid and propanoic acid. Whether it's a test used for the distinction between carboxylic acid, no. But there is one carboxylic acid, that is HCOOH. This carboxylic acid, no doubt it has got this carboxylic acid functional group. In addition to that, this compound also got an aldehyde functional group. Due to the presence of aldehyde functional group, this carboxylic acid can reduce both Fehling solution as well as tolerance reagent. Generally, carboxylic acid do not react with the Fehling solution and tolerance reagent. They are not used for classifying the corresponding carboxylic acid. This one, only this compound, that is found to be formic acid or methanoic acid. This one, since it contains an aldehyde functional group, it can combine with, it can reduce the tolerance or Fehling solution. So, only first option is correct. It is mainly because of the presence of an aldehyde functional group in case of methanoic acid. Only one carboxylic acid, that is methanoic acid, can reduce both the tolerance reagent as well as what? Fehling solution. Question number 41. The correct acidity order of the following compound is, this is phenol, next one is a chlorophenol, after that benzoic acid, next one para-methyl benzoic acid, it is also called as para-toluic acid. Out of these four compounds, which is the strongest acid? First two are phenol, next two are carboxylic acid. This is the carboxylic acid contain methyl group. Methyl means it is electron releasing group, it shows plus I effect. Wherever the compound exerts certain amount of plus I effect, that compound is less acidic when compared to normal benzoic acid. So, third compound is found to be stronger acid than the fourth compound because both are carboxylic acid. Chlorine is exhibiting about minus effect. Presence of electron withdrawing group always increases acidity of the respective phenol. It is a second compound and the least acidic is said to be first one. It is a 3-4-2-1. 3-4-2-1 means this is 3-4-2-1. Here is mistake. This instead of 2, it should be 1. So in that case, 3-4-2-1 means only first option is correct. First two are phenols, next two are carboxylic acid. Carboxylic acids are more acidic when compared to phenol. Again, in that carboxylic acid, this one contains methyl group, which is an electron releasing group, and its acidity is going to be less when compared to a simple carboxylic acid. Question number 41, correct option is said to be only first one with that simple correction. Question number 42, the strongest acid among the following compound is. First one is methanoic acid, ethanoic acid is the next one is formic acid or methanoic acid. Next one is said to be an chlorine substituted compound, CH3, this is CH2, after that CH, next one Cl, next one it is COOH. After that, next compound is CH2, it is Cl, CH2, after that CH2, next one it is found to be COH. Now in case of this compound, it is called as 2-chlorobutanoic acid, this is called as 4-chlorobutanoic acid. Between these two compounds, 2-chlorobutanoic acid is found to be more acidic because chlorine is very, very near to the carboxylic acid. Inductive effect, you know that it depends upon the distance. When it depends upon the distance, this is very nearer to the carboxylic acid. So this compound is found to be stronger acid out of these four compounds. So option number 3 is correct for this particular acidity of carboxylic acid. These two are aliphatic carboxylic acid. Those aliphatic carboxylic acids are having lowest amount of acidity. Only third option is correct here. Question number 43. The end product of the sequence of reaction is, first compound is alkyl halide. It is treated with Cn minus. When alkyl halide combines with Cn minus, what is the compound? It forms RCN, alkyl cyanide. This alkyl cyanide on treatment with sodium hydroxide, it undergoes alkaline hydrolysis. Whenever cyanide undergoes alkaline hydrolysis, it converts into an carboxylic acid with sodium salt. Sodium salt of carboxylic acid is produced. Alkane is not correct. Carboxylic acid is not correct. Sodium salt of carboxylic acid is found to be correct, and ketone is found to be incorrect. This is found to be. Whenever this is subjected to the process of hydrolysis, there the compound obtained is said to be an carboxylic acid. This carboxylic acid is produced during the acidic hydrolysis. Between whenever it is carried out about alkaline hydrolysis, the compound is said to be an sodium salt of carboxylic acid. That is option number 3 is correct for this question. Question number 44. Among the following compounds, the most acidic compound is, which is the most acidic compound? Paranitrophenol, para-hydroxybenzoic acid, ortho-hydroxybenzoic acid. Next one is para-tolvic acid. We'll write the structure of all these compounds. First one is paranitrophenol. First one is paranitrophenol. Nitro is an electron withdrawing group. Para-hydroxybenzoic acid. Para-hydroxybenzoic acid. This is COOH, and here it is OH. Next one is ortho-hydroxybenzoic acid. Ortho-hydroxybenzoic acid, COOH, and OH is here. After that, para-tolvic acid is there. Now this is COOH, and this is para-tolvic acid. They are asking more acidic compound, most acidic compound out of the 4 compounds is. It is an phenol. Leave about that phenol. It is less acidic when compared to remaining three compounds. Now this is found to be the OH present at the para position. This is present at the ortho position. Now for this compound, there is an ortho effect is applicable. If any compound in which carboxylic acid, in any carboxylic acid, if ortho position contains a substituent, that compound is always stronger acid in nature. Already we have discussed in one of the previous question. So this 2-hydroxybenzoic acid, it is also known as commonly salicylic acid. This compound is strongest acid out of these 4 compounds. So third option, ortho-hydroxybenzoic acid or salicylic acid is the strongest acid, and this one is the weakest acid because this is an phenol. Rest of the 3 compounds are carboxylic acids. 45. The carboxyl functional group is present in. Carboxyl functional group is present in picric acid, barbituric acid, ascorbic acid, and aspirin. Picric acid, you know very well, it is a 2,4,6-trinitrophenol. This is NO2, this one is NO2, next one here also NO2 is present. This compound is commonly called as picric acid. There is no COH group. They are asking COH group is present in. Barbituric acid, this one is an amide compound generally. It is C double bond O, this is C double bond O, this is C double bond O. It is NH, and this one is found to be NH. This compound also does not contain carboxylic acid group. Ascorbic acid, commonly called as vitamin C. This compound also contains ester and OH group. There is no presence of carboxylic acid group, but aspirin is a compound. It is commonly called as acetyl salicylic acid. This compound is known as aspirin or acetyl salicylic acid, and this one has got presence of COH group. So COH group is present in case of only aspirin compound. Rest of the compound does not contain what? Carboxylic acid group, but even then they're going to be called as acids. 46. The compound that does not liberate carbon dioxide, on treatment with aqueous sodium bicarbonate solution is benzoic acid, benzene sulfonic acid, salicylic acid. All these 3 are containing COH group. All benzoic acid contain this one, and this one is going to be the compound contain SO3H group. Instead of carboxylic acid, it contains sulfonic acid, but carbolic acid is there. Carbolic acid is found to be an phenolic OH group is present, but it is acidic in nature. It cannot displace carbon dioxide from sodium bicarbonate solution. Reason is that it is an weaker acid. Since the acidity of this compound is found to be very, very less, it does not liberate carbon dioxide from the sodium bicarbonate. So option number 4 is correct. Main reason is found to be it is a weaker acid when compared to carboxylic acids or sulfonic acids. Aspirin is also known as, just now I have mentioned about the structure of this aspirin. It is COOH and it is OCOCH3 is there. This compound is commonly known as aspirin acetyl salicylic acid. Acetyl salicylic acid is commonly known as aspirin. What is the role of aspirin? It is considered as an analgesic as well as antipyretic to reduce the body pain as well as corresponding body temperature. We're going to be using this particular substance, analgesic and antipyretic. 47, first option is correct. 48, what is the main reason for the fact that carboxylic acid can undergo ionization? Carboxylic acids, why they undergo the process of ionization? RCOOH is there. Whenever this one is subjected to the process of ionization, here it produces RCOO minus and this one is H plus. What is the main reason for the ionization of this one? It is mainly because of resonance stabilization. Because of the stability, attainment of stability by using the resonance stabilization, because of that reason carboxylic acid generally undergoes ionization. Absence of alpha hydrogen, that is not correct. Resonance stabilization of the carboxylate ion, that is found to be correct. High reactivity, it is not correct. Hydrogen bonding. Hydrogen bonding means it should not undergo ionization, it should undergo association. So this carboxylate ion, RC double bond O, this is O minus will be there. In the next resonating structure, these electrons are involved here and this electrons will be shifted here. It is RCO minus and this is double bond oxygen. Further, this is having partial double bond character here. In case of this one, partial double bond character is going to be obtained, which is found to be more stable. Because of that reason, there is a process of ionization of the respective carboxylic acids. 48, correct option is only second one. 49, which of the following would be expected to be the most highly ionized in water? Most highly ionized in water means most acidic compound. First one is known as, it is 1, 2, 3 is there, CH2. It is called as 4-chlorobutanoic acid. 4-chlorobutanoic acid. Okay. Next compound, it is called as a 3-chlorobutanoic acid. 3-chlorobutanoic acid. Next compound, it is called as 2,2-dichlorobutanoic acid. Butanoic acid. Last one, it is called as 2-chlorobutanoic acid. Question is what? Which of the following compound would be expected to be most highly ionized in water? Highly ionization takes place when the compound is more acidic in nature. Out of these 4 compounds, third compound is a compound containing 2 chlorine atoms. 2 chlorine atoms means maximum amount of minus I effect is applicable. When the compound is said to exhibit maximum amount of minus I effect, it can act as electron withdrawing groups. Rest of the compound contain only one chlorine atom, but the third compound contains 2 chlorine atom. Whenever there are 2 chlorine atoms are there, maximum amount of minus I effect is applicable. That compound is highly acidic in nature. When the compound is highly acidic in nature means it can be ionized to the maximum extent. 49, option number 3 is correct. HCOH shows all the test of aldehydes because already have explained in previous question. Formic acid is the only carboxylic acid which contains an aldehyde functional group. Due to the presence of this aldehyde functional group, it can reduce Tollens test, it can reduce the filling solution, and it shows the properties just like an aldehyde. It has one aldehyde group. This is the correct answer. It is a member of aldehyde. It is not correct. All acids show this test of aldehyde. That is also not correct. Does not show any test. That is also incorrect. Only correct option for question number 50 is first one, since it contains an aldehyde functional group. Which one of the following order of acid strength is correct? Carboxylic acids are there, alkynes are there, water is there, and alcohol is there. Carboxylic acids are always stronger acid when compared to rest of the compound. Next to this one, it is found to be H2O molecule. After that, it is found to be generally alcohol compounds. Next to alcohol, it is found to be respective alkyne compound is there. This is the correct order of acidity of all the compound. Carboxylic acids are more stronger acids and alkynes are found to be weaker acid. But here, one exception you have to understand here. Compared to this one, suppose if I write the compound CH3OH, next one it is found to be water, next one C2H5OH. This is the correct order of acidity of this alcohol. Methanol is exceptionally stronger acid when compared to water, except methanol. Remaining alcohols are found to be less acidic in case of water. Only methanol is found to be stronger acid when compared to water. This is the order applicable for acidity of compound. Just you remember, methanol is a stronger acid when compared to water. First one carboxylic acid is there. Next one water. Second option is wrong. First option is wrong. Next one after that water, it is alcohol. So this is H should be there here. This is found to be the correct option. Third one is found to be correct one for acidity of these compounds. 52. The reagent that can be used to distinguish between methanoic acid and ethanoic acid is methanoic acid is HCOOH and ethanoic acid is CH3COOH. Both are carboxylic acid. When both are carboxylic acid, which reagent is going to be used? And remember, whenever the question is related to methanoic acid, remember presence of aldehyde. When it contains aldehyde, this one can give positive tolerance test, positive filling solution state, but these compounds are not only this one, remaining all carboxylic acids are gives negative tolerance test and negative filling solution test. Ammoniacal silver nitrate solution means it is an tolerance reagent. First compound methanoic acid gives a positive tolerance test and this one gives negative tolerance test. With respect to tolerance test, here it forms a black precipitate, but here there is no formation of any black precipitate or shining silver mirror. So ammoniacal silver nitrate or tolerance reagent can be used to distinguish these two carboxylic acid. Actually, this is also carboxylic acid, but because of the presence of aldehyde functional group, it shows or it exhibits the properties of aldehydes also. So first option is going to be correct. Neutral ferrichloride, this is going to be applicable for distinction phenol and other compounds. Sodium carbonate, both will answer for sodium carbonate, both will liberate carbon dioxide. Phenolphthalein can be used only for acid base indicator. So first option is correct here. Question number 53, hydrolysis of an ester gives acid A and alcohol B. A reduces filling solution and oxidation of B gives A. The ester is. Let us first start with methyl formate. Methyl formate is a compound. This is HCOOCH3. This compound is called as methyl formate. Hydrolysis of an ester, whenever this one undergoes the process of hydrolysis, what is the product is obtained? The product gives HCOOH plus this one is CH3OH. It is going to be considered as acid. A is there and an alcohol. This one is going to be B alcohol. A reduces filling solution. Whether this reduces filling solution? Yes. Why it reduces the corresponding filling solution? Just now I mentioned about this one aldehyde functional group. It can reduce the corresponding filling solution. And oxidation of B gives A. Methanol, when it undergoes the process of oxidation, it gives us to single carbon atom carboxylic acid. It is also containing one carbon atom. This is also containing one carbon atom. Methanol on oxidation gives the corresponding carboxylic acid, though the corresponding ester in this reaction is going to be only first one, that is going to be methyl formate compound. Methyl formate on hydrolysis gives these two compounds. One is methanoic acid, next one is methanol. Methanoic acid can give filling solution test because of the presence of aldehyde. When methanol undergoes oxidation, it forms what? Methanoic acid. Alcohols on oxidation produces carboxylic acid containing same number of carbon atoms. So only option first one is correct. Right order of acidic strength is, they have given different compounds. CH2Cl COOH is there. First one I'll write CH2Cl, this is COOH. Next compound is HCOOH is given, formic acid. After that CH3, this is CH2COH, nothing but C2H5COH. Last one is CH3COOH. Among these compound, which is the strongest acid? This is the compound containing chlorine atom which exhibits maximum amount of minus acid. This is found to be stronger acid. Next one is found to be formic acid. This one is going to be there. This is found to be stronger acid. But between these two acids, remember, it is methyl group is this one is ethyl group. It is showing maximum plus I. maximum plus I. This one also shows plus I, but minimum plus I. So between these two compounds, this compound is stronger acid. First one, chloroethanoic acid is there. Next, last two options are incorrect. After that, formic acid, next one correct. CH3COH is found to be correct. This is C2H5 should be there. This compound is a weak acid, and the correct order of acidic nature of that compound is second one. 54, it's second option. The reaction CH3COH plus Cl2 in presence of phosphorus gives ClCH2OH. That is an example for Hale, Ollard and Zelinsky reaction. When alpha hydrogen atoms are replaced by the halogen atom, they form alpha halo carboxylic acid. This is an example for Hale, Ollard and Zelinsky reaction. Nitration of benzoic acid gives, whenever benzoic acid undergoes the process of nitration, this is HNO3 and H2SO4. HNO3 and H2SO4. The nitration of this benzoic acid converts into meta-nitrobenzoic acid because COOH is an electron withdrawing group. Electron withdrawing group means always it forms meta-isomers. So here it converts into meta-nitrobenzoic acid, or it is 1, 2, 3 nitrobenzoic acid. So first option is correct here. Always it forms a meta-isomer, but you remember this one benzoic acid molecule does not undergo Friedel-Crafts reaction because the reaction takes place between COOH and this one AlCl3, which is an Lewis acid. Because of that reason, this compound does not give Friedel-Crafts reaction. 57. CO2 on reaction with ethyl magnesium bromide gives. Ethyl magnesium bromide on treatment with CO2, carbon dioxide. So here product is said to be C double bond O MgBr takes place. Actually, we have to carry out further hydrolysis process. When hydrolysis is carried out, the compound produced is said to be this one, C2H5COOH. It is called as propanoic acid, 3-carbon atom carboxylic acid, propanoic acid. In the question, it should mention about the process of hydrolysis. So second option is correct in that case. 57, second one. When benzyl alcohol is oxidized with KMnO4, the product obtained is benzyl alcohol is oxidized. This is CH2OH. Whenever this compound undergoes the process of oxidation, alcohols are converted into respective carboxylic acid here containing same number of carbon atom. Product is and benzoic acid. So option number 2 is correct. 59. Which of the following on hydrolysis forms acetic acid? Hydrolysis of CH3CN. Cyanides upon hydrolysis, remember clearly, whenever cyanides undergoes hydrolysis, they form carboxylic acid containing same number of carbon atoms. Which of the following hydrolysis forms acetic acid? This is an acetic acid. It is obtained from methyl cyanide. This one generally does not undergo the process of hydrolysis. This is also alcohol, no hydrolysis. This one on hydrolysis, it forms C2H5. This one is OH. Formation of alcohol takes place. 59. Its correct option is first one. Last one, 60. Acetic acid will be obtained by the oxidation of ethanol, propanol, methanol and glyoxal. Whenever ethanol undergoes, that is ethanol, alcohol, whenever ethanol undergoes oxidation, they produce respective carboxylic acid containing same number of carbon atoms. Ethanol gives rise to corresponding ethanoic acid, propanol. Propanol means this is CH3, it is CH2, CHO. Propanol upon oxidation process, it forms again respective carboxylic acid, but it is propanoic acid, but they are asking about acetic acid compound. So correct option should be only ethanol. Ethanol gives acetic acid. Methanol gives, what is methanol? Methanol is HCHO compound. This one on oxidation gives what compound? HCOOH, that is methanoic acid. But they are asking about acetic acid. Only option number first one is correct. This is the discussion based upon two topics. One is carboxylic acid. Next one is going to be which one? Surface chemistry. 60 questions we have completed in almost 1 hour and 15 minutes. All the 60 question discussion is completed, and next you are writing the examination based upon this carboxylic acid and what colloidals, that is surface chemistry, and all the best. Thank you.